Ah, coffee, that warm, inviting aroma. For billions, it's the ultimate morning ritual. The sun peaks over the horizon, the alarm clock groans, and what's one of the first things many of us reach for? That glorious cup of coffee. It's more than just a beverage, isn't it? It's a signal that the day is about to begin, full of possibilities. It's a comforting friend that helps us face whatever challenges lie ahead. From bustling city cafes to quiet kitchen counters, coffee is there. People sip it while reading the news, commuting to work, or during important meetings. It's a social lubricant, a moment of personal peace, a jolt of energy. Consider the sheer variety. Espresso, latte, cappuccino, drip, cold brew, so many ways to enjoy these roasted beans. Each culture has its own unique coffee traditions, its own special way of preparing and savoring this beloved brew. So what is it about this dark, rich liquid that holds such sway over us? Is it just the taste, or the warmth? While those are certainly part of its charm, there's a powerful secret ingredient at play. We're talking, of course, about the one, the only caffeine. Let's dive in. Caffeine, you've heard the name, you've probably felt its effects. This is the primary active compound in coffee, the main reason your morning cup gives you that much-needed boost. It's a naturally occurring chemical, a stimulant, found not just in coffee beans but also in tea leaves, cacao pods, hello chocolate, and cola nuts. Caffeine is, scientifically speaking, an alkaloid, a class of naturally occurring organic compounds that mostly contain basic nitrogen atoms. Think of caffeine as the key player, the MVP in your coffee. When you drink coffee, you're essentially inviting this tiny titan into your system. It gets absorbed pretty quickly too. From your stomach and small intestine, it travels into your bloodstream. And once it's in your bloodstream, guess where its favorite destination is? That's right, your brain. It can cross the blood-brain barrier, a very selective filter that protects your brain, with remarkable ease. Its role as a stimulant is what makes coffee so effective at waking us up. A stimulant is something that raises levels of physiological or nervous activity in the body. It makes you feel more alert, less tired, and sometimes even more focused. So, caffeine is the star. Are you ready to get into the nitty-gritty of how it works? I thought so. Let's zoom in way into the molecular level. What does caffeine actually look like? If you could shrink yourself down like Ant-Man, you'd see that caffeine, or C8H10N402 for you chemistry buffs, has a specific and very important structure. It's a member of the xanthine family of alkaloids. Other members of this family include theophylline, found in tea, and theobromine, found in chocolate. The structure of caffeine is a beautiful arrangement of carbon, hydrogen, nitrogen, and oxygen atoms. It features two fused rings, a pyrimidinedione ring and an imidazole ring. This precise three-dimensional arrangement allows it to interact with certain parts of our neural machinery in a very particular way. This molecular structure is remarkably stable. It doesn't break down easily when you roast coffee beans or brew them with hot water. The way these atoms are bonded together gives caffeine its characteristic properties, including its ability to dissolve in both water and fats, which helps it move through the body and cross that all-important blood-brain barrier we talked about. So when you're sipping your coffee, remember that you're ingesting billions and billions of these intricately structured molecules. Next up, what exactly is it interacting with? Now, to understand how caffeine works its magic, we need to meet another molecule. This one is produced by our own bodies, right inside our brains. Its name is adenosine. Think of adenosine as your brain's natural sleepy time signal. Throughout your day, as your brain cells work hard, thinking, learning, processing information, they produce adenosine as a byproduct. The longer you're awake and the more active your brain is, the more adenosine builds up. This accumulation of adenosine is a crucial part of how your body regulates sleep. As adenosine levels rise, it starts to bind to specific receptors on your neurons, kind of like a key fitting into a lock. When adenosine docks onto these receptors, it has a calming effect. It slows down nerve cell activity. It makes you feel drowsy, tired, and ready for a rest. It's your brain's way of saying, okay, I've been working hard, time for a break to recharge and clear out this adenosine. But what happens if something comes along and interferes with this sleepy signal? What if something could temporarily block adenosine from doing its job? I wonder what that could be. This is where our friend caffeine makes its grand entrance. Remember caffeine's specific molecular structure we talked about? Well, it turns out that caffeine looks remarkably similar, on a molecular level, to adenosine. It's not identical, mind you, but it's close enough. Caffeine is like an adenosine impersonator. It can sneak up to those adenosine receptors in your brain, and because of its similar shape, it can fit right into them. It's a molecular mimic. So caffeine molecules arrive in your brain and they see these adenosine receptors. Instead of adenosine docking there, caffeine slides in and occupies the spot. It blocks the adenosine from binding. Crucially though, while caffeine can fit into the receptor, it doesn't activate it in the same way adenosine does. It doesn't send the slow down, get sleepy signal. It just sits there, taking up space, preventing adenosine from delivering its message. This blockage is the absolute core of how caffeine exerts its stimulant effects. By preventing adenosine from binding, caffeine essentially puts the brakes on the brain's natural calming mechanism. So, caffeine is blocking adenosine receptors. What happens next? The immediate result is a decrease in that feeling of drowsiness. The sleepiness that adenosine was trying to promote is held at bay. Your brain, no longer getting those slow down signals, continues to operate at a more active pace. This is why you feel more awake, more vigilant, and less fatigued after a cup of coffee. This isn't just a feeling, it's a measurable physiological effect. With adenosine out of the picture, or at least significantly hindered, other natural stimulants in your brain, like dopamine and norepinephrine, can have a more pronounced effect. Nerve cells can fire more rapidly. This increased neuronal firing can lead to improvements in various cognitive functions. You might find your reaction time is quicker, your ability to pay attention might increase. Tasks that require sustained mental effort can feel a little bit easier. The extent of this increased alertness can vary from person to person, but the underlying mechanism, the blockade of adenosine receptors leading to reduced drowsiness and increased neuronal activity, is the same for everyone. But wait, there's more. Caffeine's influence doesn't stop at just blocking adenosine and making you feel less sleepy. Its presence in the brain can trigger a cascade of other interesting effects. One of the most notable is its impact on dopamine, a neurotransmitter famously associated with pleasure, motivation, and reward. While caffeine doesn't directly cause a massive surge of dopamine like some other substances, it can indirectly enhance dopamine signaling. By blocking adenosine receptors, particularly a type called A2A receptors, caffeine can disinhibit dopamine D2 receptors. When caffeine takes adenosine out of the equation, dopamine can function more freely. This can lead to a mild improvement in mood, an increased sense of well-being, and even enhanced motivation for some individuals. Furthermore, caffeine can also stimulate the adrenal glands to produce more adrenaline, also known as epinephrine. Adrenaline is the fight-or-flight hormone. It can increase heart rate, open up airways, and get your muscles ready for action. This contributes to the overall energizing effect of coffee, making you feel more physically capable and ready to tackle challenges. It's a symphony of chemical reactions happening inside your amazing brain and body, all orchestrated by that one little molecule from a humble bean. Science is everywhere. Now, as with most things in science and in life, there's a balance to be struck. Caffeine is pretty awesome, but it's not without its potential downsides. While moderate consumption can offer those wonderful benefits of alertness, improved focus, and even a mood lift, too much caffeine can lead to some not-so-great effects. One common issue with excessive caffeine intake is anxiety or nervousness, often described as the jitters. Another significant downside can be sleep disruption. Since caffeine's job is to block the sleepy molecule adenosine, drinking coffee too close to bedtime can make it really hard to fall asleep or stay asleep. Then there's the issue of tolerance and dependence. If you drink coffee regularly, your brain can adapt to the constant presence of caffeine. It might start producing more adenosine receptors to try and counteract caffeine's blocking effect. This means you might need more caffeine over time to achieve the same level of alertness, and if you suddenly stop drinking coffee, you might experience withdrawal symptoms like headaches, fatigue, and irritability as your brain readjusts. So, the key is mindful consumption. Coffee. It's more than just caffeine, isn't it? Coffee shops are community hubs, meeting places for friends, quiet corners for students and writers, and bustling centers of commerce. From Ethiopian ceremonies to Turkish coffee, café au lait in France and espresso in Italy, coffee tells stories of tradition and global trade. The science of caffeine is fascinating. Knowing this enhances the magic of coffee. So next time, think about the journey of those beans. Cheers to coffee and science.